So, welcome everyone, and thank you so much for joining us today. We are beginning this day with this webinar on system thinking and career in system engineering. And I'm sure you're not going to regret. You're going to learn a lot of things from Sir because he is a master in system thinking engineering. So, let me introduce you to our dear mentor, Mr. Rajkumar Gokharu, sir. Sir has postgraduated from IIT Delhi in machine design and has done MBA in marketing with certification course in systems engineering from University of New South Wales, Sydney, Australia. He worked in various MNCs in the automotive, aerospace, process and healthcare industries. His 20 years of experience includes new product introduction, R&D, simulation and engineering management. And in this topic is about system thinking and careers in system engineering, which has wide spectrum coverage across various engineering streams and industries. In this webinar, we will discuss how system thinking is hypothesized as a major high order thinking skill that enables individuals to successfully perform systems engineering tasks. So, thank you so much, sir, for taking this very unique and very informative webinar on system thinking with us. And I'm sure we are all excited to learn from you because, as per your experience, this is going to be a very, very, very beneficial webinar for everyone. Thank you so much, sir. Over to you.
Yeah, thank you, Preeti, for nice introduction, and thank you everybody for joining the webinar. My name is Rajkumar Gokharu, and I am an associate career mentor at Dheya, guiding students and mid-career professionals to choose the right career goal and path forward. And Preeti has already given an introduction. I will move to the topic which where we will talk about the system engineering and how system thinking help in making a good career in systems engineering. So let's first talk about the systems engineering. So engineering was born in 1960 at NASA. Means NASA when have a complex products, everybody knows that complexity of products is rocket launcher and space shuttles and all those are so complex that developing the those was a challenge, and NASA came out with systems engineering principles and processes to do the complex product developed in a simple form, as well as to streamline the efforts of all the streams like mechanical, electrical, civil engineering, software engineering, as well as all other project management and associated work. So system engineering integrates all the disciplines into team effort and forming a structured development process from the concept to implementation in the field. And what it result is integration is the key word here, which is very very important. So each department work in their own area and develop the product or services or the processes in their own field. However, at the end the product encompasses all in one, and that's where the system engineering principles or system engineers comes into picture, and from the beginning to end they will integrate all things together and bring the product quality product at the time and cost. So considering both the business and technical needs of the all the customers, the goal is to provide quality product that meets the end user needs. So system engineering is such a huge umbrella that there is an international council on system engineering in course, which is a very well recognized and well standard council, and is designed to connect system engineering professionals across the world. So we will talk little more detail about the in course and how different stages the career option provided by the in course, and what are the career advancement opportunities through in course. So just to give a glimpse here at the beginning, it defines what is system engineering. It gives a glimpse of total all about system engineering processes and its in cause impact. So it actually lead from the front for the future of systems engineering. And one can grow in system engineering. There is a path shown by Incos in three-step path, and we will talk about that in the career slides at the end of this program. So system thinking. Now, in order to have a good career or a good system engineer, system thinking is very much essential. And what does it mean? A better world through system approach. So, knowing, if I say the 10 qualities of a systems engineer are the person who has these abilities or qualities will be more successful in systems engineering. In patience and perseverance, ability to know more when you are done, okay, an analytical brain. So being an engineer, we already have that analytical thinking and analyzing the things, doing analysis, that is analytical brain. Then knowledge of systems engineering tools. So system engineering can be learned at the graduation level, post graduation level, or it can also be learned as a professional. So if you are as a student, and if you learn in the college as a full time course or as a subject, or if you are in the profession already in the job, then you can go through various courses through Incos or through Coursera or through other university courses on the systems engineering, and learn about it to build your career in systems engineering. Then strong organization skills, ability to see small and big pictures. So system engineers as a system thinking must have ability to see the big picture as well as the small picture, the micro level and macro level we talked about. So we'll go through it in detail in the coming slide. Then well rounded background. So what exactly it means is, it encompasses, as we see, it integrates all the discipline. So when it one has to integrate all the disciplines and bringing them together for developing a complex product, a well-rounded background is helpful. Then of course the communication skills, the better the communication skills, better to lead, follow and work well in a team and to integrate everybody's work. So if in the similar way, if I talk on the individual traits on the right side in the circle, individual traits that enable system thinkings. So I would like to touch upon the couple of more points here. Like, one is tolerance for ambiguity. So when a complex project or some complex product is built, it takes couple of years, 2 3 4 years of development time, and lot of ambiguity will be there at every stage of the project or the product development phase. And that's where a system engineer should be capable of dealing with those ambiguity. He should be curious and openness of ideas, and curiosity to learn will help in, as we understand that he should be well rounded. Well rounded means he should be curious to learn, and then openness will help him to get the ideas and the concepts to understand from each and every one. And the other one I would like to touch upon is ask the right question. The system engineer is well experienced system engineers I have seen in the field, uh, which are well means ask they ask the right questions. So every is subject knowledge may not be they be having in-depth knowledge, but to bring the product uh, in a good quality shape, they learn how to ask the right questions, so that at the end of the day solutions comes out well. So this is all about the systems thinking, and system thinking's principles are then get applied in the systems engineering, and individual with these traits that enables the system thinking in it will able to implement the system engineering process. So we will talk now little bit about the system engineering process. And if you see here, it's a v-shaped process which starts from concepts of operations to end at operations and maintenance. So let me walk you through the steps one by one. So concepts of operations is the high level uh, start of the project, and then the requirements and architecture is defined. So before even going into the detailed design, all the requirements are well clarified, and the product architecture is defined, and detailed design is then done by I will say individual department, mechanical, electrical, software, and so forth, and human centered design, all those done in detailed design. Then the implementation is basically prototyping it and checking the design. Now, since the integration will be done at the other end, which is the system engineer's job, integration, test, and verification, and then system verification and validation. These two are the crucial role, and these two crucial roles are held by the system engineer, do verification and validation at every stage. Means, so if you see the v shape, why it help in v shape is at concepts to operation and then requirements to detail design. At each step the verification is done and validation is done. If you see the middle arrow, verification and validation, that's where the system engineers comes into the picture, and is integrate, and then verify and validated systems goes to operation means in the field, and maintenance means till the end of life. So it's like from inception of the idea till the end of the life of the product, system engineers has to be responsible, and has the ownership of the system performance, quality, output, and everything. So, just to summarize it in a nutshell, that system engineer will ask right question at every steps of the this life cycle of the project, and integrate, bring all the department work together, integrate and look from the system's point of view and end user point of view, seeing that the actual deliverable system to the user, end user, should be same as what is required by the user. So that is where the whole system engineering process works. So, since system engineering is the integration of bringing all the department, or I will say all the engineering and non-engineering group together. If you see on the left-hand side, electrical, mechanical, software, just to give example here, industrial design, human factor design, all this engineering. So system engineering cut across all this engineering. Then system engineering, uh, systems requirement definition, product development phasing, even project management, it cut across, and product life cycle, and verification and testing. So system engineering is in the center of all these activities to build a complex project, and this complex successfully delivering of the project. And if you see on the right hand side, the industries, from space industries, aerospace industries, to automotive industries, shipbuilding industries, and so on and so forth. All these are very, very complex product, and that get tremendous support from system engineering and using the system engineering principles. So now what are the benefits of system engineering? System engineering reduces the risk of schedule and cost overrun and increases the likelihood that the implementation will meet the user's need. System engineering main, if you see the word risk, so risk identification, risk mitigation plan, and finally risk retirement. This is the core of the system engineering work. So system engineer should be capable of identifying the risk at the early stage of the program, as well as plan to mitigate it, and then finally it has to retire the risk over the period of the product development. That implementation will meet the user's need. So this is achieved. So how this is achieved? Improved stakeholder participation. System engineers make sure that each and every stakeholder participation is essential and taken care of everybody's view. Shorter project cycles. So system engineer has to make sure that the project cycle will be shortened and finished within the scheduled time. More adaptable and resilient system. So system robustness will come when a more adaptable and resilient system is built across. Now, verified functionality and fewer defects. So defect tracking mechanism is also again one of the core of system engineering function, where uh, every product development project has the defects, or if you see in the software terminology, bugs will get introduced, but how to detect them and how to make sure that fewer and fewer defects will pass on to the user, or the bugs pass on to the user. So at the uh, verification process should be so much strong enough that at the development phase itself, or even the testing, prototyping and testing phase, uh, or verifying of the design phase, that phase, lot of whatever defects are possible to be detected, it should get detected and corrected there, so that user will get fewer and fewer defect at the system level. And improved risk management. As I talked in detail about the risk management, which is the core of systems engineering, better the risk is identified, managed, and retired, better the product outcome will be, and that will be well versed with the system engineering. Then better documentation. System engineer always insist on the documentation part. Who has taken the decision? What is the decision taken? What are the assumptions made? What all the uh, uh, means decision factors all about, and how it is impacting the system. So at the end user and system, how it is impacting system and the end user, that also need to be documented. So right from the requirements, even the user needs and the requirements, to till the end of verification, validation, even the documenting the maintenance till the retirement of the product, is well known by a system engineer, and he is behind all the department to have better documentation. We call it GDP, good documentation practice, in the industry. And that's where a lot of benefits comes out of the system engineering. Complex the product is, complex the project is, more benefits from the system engineering. So just on the right hand side, to give a visual effect, how the customer explain it, and if individual department will do it, how the project manager understood it, how engineer design it, how technician build it, and how customer really wanted it. So in short, if as we learned about that, system engineer is the person who asks the right questions at each and every stage of the project with each and every stakeholder, and bring out with good documentation practice, he will bring out what is exactly required, and what is delivered is matching what is required. So each and every department, if you see the picture on the right hand side of the slide, everybody looks differently, understand differently, try to give output differently, but that's where the system engineers comes into picture, and make sure that everybody understand on the same page, and they deliver what is required and not as per what they understand. So that's where a system engineer plays a very vital role in bringing everybody's together, and their system thinking. As we talk about system thinking, that is the core of system engineer, and system thinking principles to he or she applied to bring out the benefits, and not create different solutions for the same problem, and give a different output than the requirement, as shown in the picture. So just to talk a little more about, now we have talked about system thinking, systems engineering, the process of systems engineering, benefits of system engineering, and let's talk about some career options in systems engineering. So there are a lot of courses at masters and PhD level in Indian Institute of Technology, that is IITs, well recognized institutes across the world. Okay, and in IITs you can have masters and PhD courses in systems engineering. At the same time, if you want to have bachelor's and master's degree in systems engineering, you have a lot of engineering colleges in India and abroad who provide bachelor's and master's degree in systems engineering. Now these are for the more for the student level who has a plan to build career in systems engineering, or they are yet to start their career and they are in the college uh, itself, at bachelor stage or master stage. Now what about those who are in the profession? So those who are already working as an engineer, design engineer, or product development engineer, or software engineer. So those who want to build their career in systems engineering. So INCOS, as we talked about, the International Council of Systems Engineering has a certification course, professional certification course recognized well across the world. So there are three levels of INCO's system engineering professionals. Associate, first one is associate, second is certified, third is experts. So let's understand little bit in detail about those. Associate is one who first gain the knowledge about systems engineering, and try to apply in bits and pieces of those knowledge in the uh, system engineering, and learn the tools and techniques of systems engineering. Okay, obviously he will work with certified system engineer or expert system engineer under the guidance of experts in system engineer, and try to learn and implement the basics. The second one is certified system engineering professional. Certified, so INCOS give the certified when the individual will handle couple of projects and implement system engineering principles, system thinking principles, and complete benefits the organization, as well as gain the experience in those in the system engineering field. So then INCO certified that as a CSEP. Okay. Then the expert. Now there are very few at this level, at the expert level, system engineering professionals. They have to not only work within their industry and implement the system engineering principles, gain the experience, but they have to also help associate, even in some case certified system engineering professionals, to overcome those difficulties they are facing in implementing system engineering, as well as the expert level. They have to define the roadmap along with the in-course body. They have to define the roadmap for system engineering in future, the various career options for system engineering, and material of teaching the system engineering, guiding and mentoring other system engineers, and means presenting at the webinars. Not Earlier it would be more on the seminars and other uh, conferences. So that is where the experts system engineers has been defined, that is ESEP. So, knowing about the career, how to build a career in system engineering, let's also understand what a system engineer do and where he or she will get a career in. So, a system engineer is generally found in large corporation. Why large corporations? As we understand that it's a complex projects or product that get benefited most through the system engineering principles. So that generally is found in large corporations and works with other industry professionals to meet the needs of customers and clients. So system engineers may work in an office setting or in manufacturing plant. Yes. So as we have learned that system engineering engineers work is to integrate and to work with industry professionals across the different streams. So that's where the system engineers may work in office or in manufacturing plant, but he has to interact with almost all the department in an organization and integrate their work, and keeping system thinking in mind, and the end product as a system. uh, so that's where different positions are offered to system engineers, are at systems or senior systems engineer, that is more at the associate and certified level, and head systems engineering or a system engineering manager, which is at expert level. The few industry examples, as we talked about, that there are a lot of industries, but the where it started in the space industry, the NASA, as we talked about it in 1960, it started from there, and then used by military, aviation, automotive, healthcare, and so on and so forth. So system engineering is basically now getting its foot in many complex product development and many more industries. Just a few are mentioned here as an example. So, with this one, we almost come to an end of this webinar, the main material. However, to explain little bit more, and those who has more curiosity, I have prepared couple of more slides to just have a better understanding. So, as we talked about the function of systems engineer. So, what is the function of system engineer? As we talked about, he should have a integration objective, integrating the works of all the department and look as a system. So, and ask the right questions at every stage of the project. So we have seen the system engineering process as a v-shaped. So same way, this slide is showing the v-shaped product development. So first is the project objectives. As we see, it's blur, so it's done with intention. that at the beginning of the project lot of ambiguity is there, and crystal clarity is not there. So from there to concept formulation and requirement definition, system engineer has to play a role and bring the much clarity, at least at the level, the product architecture level, what should be the product look like and how it will be, what are the major functions of it, and then decompose and define for individual one. So decompose and define for each department what will be the hardware piece, what will be the software piece, what will be the administrative piece, project management piece, fit, and then design and build the parts. So once at the bottom, design and build the parts. So now each system is composed of subsystems, and then subsystems composed of parts. So what matters to system engineer is at the end, how does my system will work, okay, even though my parts and subsystems working little differently, but when integrated, so when we move little up, are these the right parts and designs? Why? Because when these are integrated, will they function as intended? Are these the right? Again, he will ask, because when these parts will get integrated into subsystems, and will they function properly as intended? And then when integrated into a complete system, is this what we mean to build? So he will check from what is defined at the beginning, okay, and then when it get delivered to the customer end user, is that what project was wanted or a requirement as per the customer's requirement? So these are the points which at every stage of product development system engineer keep track of, and reminding each and every department where they have to focus to bring the end effect better, rather than focusing only on the individual components and individual sub-assemblies. Okay, and how a change in individual parts or sub-assemblies will affect the end product or the system at the end. So are these right components fundamentally, logically, and physically? These are the basic very system engineers have is in their minds. And do they meet the needs of the higher systems? So they always look from the system point of view. So at the end of the day, the system is what is seen by the user and used by the user, and that will deliver the results. So they meet the needs of the higher system, which is a little bit less think about by individual department. As I mentioned, the individual department think more about their subsystem, their components, and those, and integration is the thinking done by the system engineer. Are they compatible? So are they compatible means when these uh, subsystems integrate with each other, are they talk with each other properly and build a system that functions well? That is what system engineer function is. So this is a very exciting function, and each industry is building complex products are going through the system engineering principles. So just to summarize and just to give a practical look to it, we have talked a lot about the theoretical of it. Now the system engineering integrates everybody's view. What does that mean actually, and how it has been done? So uh, as we see an example of a car door, okay, so uh, the requirements are, if I read the what is written here, I want a car door, okay, as an output, that will be a requirement. strong structure, hinged, latched, can be opened from both the sides. So all these requirements uh, with clarity goes to one after another. Individual departments segregate into the buckets, and as and when the requirements get added, if you see I want to see out and open the window, so it's start getting from mechanical to electrical, getting added to it. Then uh, once the electronics get added to it, it require to be automatic operated buttons and all those. The software comes into the picture, embedded software comes into picture, and safety comes into the picture, the ergonomics, safety, human factor engineering. So it's looks like a simple door or a simple product. However, when multiple uh, functionality are required, and it has to be integrated into seamless fashion, that's where the system engineer will come into picture, and he will talk with all the departments and bring the requirements, clarity in requirements, such that each one try to build together a system which will meet the end user's need. With this one I am done with that. So thank you everybody for attending today's webinar, and now let's look at the questions. So,
So we have questions in the Q&A section. First is by Dipankar sir. How system engineering different from software engineering as well from design thinking?
yeah. So let's first consider the design thinking part of it. So design thinking is implemented looking for a product development from the user centric point of view, and design thinking principles also involves everybody together, but that is more of applied in user centric products rather than bothering about the complexity. Here system engineering works more on the system thinking principle, where integration is the key, and risk in such complex projects are much at higher level. So risk identification, mitigation plan, and retirement is a very key aspect in system engineering. So design thinking is mainly done in the design department, while the system thinking looks at macro and micro level, both the bigger picture and technical aspect as well as business aspect of it. What was the other thing, Priti?
Yes, sir. So you have covered the software engineering part as well, right?
No, no. So software engineering is, I will say, one part of it, because now major chunk of the project software engineering work with the technology coming up in each and every product. So again, the system engineer has to interact with all the department, including the software engineering department, means, and integrate it. So at the end, whatever software is built is that meet the requirement of system, how it affects the system. That understanding is there with the system engineer, and he will not only interact with software department but also work with the other department to bring in that these are the software need to be implemented, then what are the electronics needed for it. If those are the electronics needed for it, what are the structure needed to hold those electronics. And in short, it should be used by the user, so it should have the usability and human factor engineering built into it. That all integration, though the core at the back end is software, has to be understood and integrated and bringing together in a fashion the system it works well for the system at the end is the system engineers work.
Okay, sir. So next question we have from Hita Jonathan. Can we consider system engineer as a product manager or product owner? How much depth of knowledge as system engineer need to have in multidisciplinary, especially in foresee risks and mitigate in advance?
Okay, so if I thank you, Hita, for asking the question. It's a very good question. So if I understood correctly, in the product development, one system engineer has to be connected with everybody. First of all, what does that mean is right from the customer to the end user, even to the manufacturing and as well as service personnel, sales personnel, he has to be in connected with everybody, and he has to work with all of these people to understand at each and every step what risk can come, what are the challenges can come, and what are the mitigation. Then he has to find the solutions for those. So system engineer is the person who brings the solution for all those challenges, and it is possible that the work done by one department brings some challenges for other department. So that's where system engineer has to understand that what challenges are coming up, and how this different departments knowledge. So knowledge get built in the system engineer over a period of time. That's where system engineering is not a outsourced job. It's not a job where service can be provided from outside. It's the person who has to be within the product development or within the knowledge of the system from long time. And that's where we see there are different phases or stages of system engineering and the knowledge. So if system engineer is at the associate level, he has to work under the supervision or guidance of the expert. So that's the role is called for a knowledge of so many department, bringing them together and understanding at the high level what are the challenges can come in every stage of product development. One require quite good amount of experience to be a system engineer, an experienced system engineer to handle independently a product or project. So thank you everybody for your time, and I hope this webinar will be helpful for you, and even those who has registered and they can see the recording later. Thank you them as well. Uh,
Sorry to interrupt you. We have one more question by
okay.
Hita, who is owning product integration, architecture design.
So product integration architecture design is uh, owned by the LSD, lead system designer, who is basically systems engineer short. So LSD is a terminology used in most of the corporate world, who is leading and owning the design. He is answerable for functionality as well as the life of the product and the outcome of the system as a whole. Yeah.
Vinayak Kumbhakarn is asking any reference reading material for system.
Yeah, so one is the website of Incos is a good reference where you will get a lot of material to read. And in this webinar, I have given the that one. And there are a lot of good system engineering books available. So the better is if you go to Coursera and do an online course of 6 to 8 weeks. It will be module by module material as well as videos with by well recognized professors that will give you good insight and as well as exercise at the end of each module to really learn in a structured and better way rather than considering a lot of reference materials. So I will highly recommend one is in course and other is Coursera system engineering courses.
So thank you so much, sir, for taking this webinar on system thinking and career in system engineering, which is very unique. And thank you so much for taking your precious time out to join hands with Dheya take to give knowledge to everyone. And thank you so much, everyone, for attending this webinar. I'm sure you had good plans, but I'm sure that from this webinar you have benefited a lot. So thank
Yeah,
you so much, sir.
yeah. Thank you, Preeti, for coordinating this, and thank you, Dheya, for giving a chance to this webinar and knowledge sharing session. And thanks everybody for joining and giving your precious time to learn and understand and discuss more about system thinking and career in system engineering.